All right. So today what we're going to do is start looking at the proofs for congruent triangles. And on your cheat sheet that you guys have, if you open up to like this second sheet right here, that's going to have some of the common steps, and there's actually one on this side too. This is going to have some of the common steps for the proofs that we're doing. So this would be something that's kind of handy for you to look at as we're going through, okay? So yesterday we talked about when two triangles were congruent, we would have to show 6 things were congruent. We'd have to show all of the corresponding angles were congruent, and we would have to show that all of the corresponding sides are congruent. Okay, that is for the two triangles being congruent. Now, in all that 6 things, and so what mathematicians found was that there are 4 shortcut ways, there's actually 5 that we will be doing, that will show us that two triangles are congruent where we don't have to say all 6 things. So today we're going to learn the first 2. And in these 2, you only have to show 3 things of one triangle being congruent to 3 things of another triangle. And that is enough to say that those 2 triangles are congruent. The first one is called side, 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 and we use SSS for it. And by the way, on your cheat sheet, I don't think I ever listed which ones. So if you off to the side wanna, as I introduce a new one, just make a list of which, or did I? Maybe on that next page. Oh, I did. They're right here. These are the ones that work. So I guess you don't have to copy it now. Okay. So the first one is side, side, side. And what that means, if you can show that all 3 sides of one triangle are congruent to all 3 sides of another triangle, that is enough to say your 2 triangles are congruent by side, side, side. And we just always write down SSS for that. Okay. This is the easiest way, and when you do these, you don't have to worry about any of the angles because they will automatically be congruent if the sides are. So now if we go to this page, we kind of did algebra proofs back in chapter 2. And when we do these proofs, we do 2-column proofs, okay? The reason they're called 2-column is we have our statements on the left side, reasons on the right, so we have 2 columns, okay? In a geometry proof that's different than an algebra proof, we have a given and a proof statement, okay? And then you'll have a diagram. And I can tell you guys right now today, people that do not use the diagrams in these proofs are going to really struggle. So everything that you find out and write down here has to be marked in your diagram. If it's not marked in your diagram, you can't write it down here. If it's not here, you can't write it in the diagram, okay? So the first thing you're going to always do is look at what you're given. And notice you're given EF is congruent to GH. And that's step 1 right here. And remember, that would just be given. The reason in every single proof the entire year is always going to be given. In a geometry proof where you're given 2 things, you're going to have 2 things that are given. So here, notice they are also telling us that FG is congruent to HE. That one's right here. So this is also given. Givens are free point, and there is not one of you that cannot do the given part of the proof. Okay. Now, another thing, as I was saying this, whenever you're given something, you're going to go to your diagram and make sure it's marked. And notice they say EF, which is right here, is congruent to GH, which is right there, and that's marked. They also tell me that FG, which is here, is congruent to HE, and that's marked, okay? Now, a super common step in these proofs is if you notice these two triangles both share this middle line. And I can then say that either EG is congruent to EG or GE is congruent to GE. And we talked about that just briefly yesterday. Do you remember what it was called if something is congruent to itself? Starts with an R.
Reflexive.
Reflexive. And when you write down reflexive, you also have to write prop. Okay? So reflexive property is whenever something is congruent to itself. Now, we want to show that these two triangles are congruent, and that's what they have down here. And your reasons for right now that we know are just SSS for side, side, side. And notice in both of these, we have all three sides marked. So we just write side, side, side. Now let's go here. So this one, we have two given. And what you're going to do is look below and see which steps. If they give you two givens, it's not always 1 and 2. It could be 1 and 3. So you do have to check. AB is congruent to CD is in step 1, and that's given. And the really important thing is, you guys, you have to get used to say, I have to mark my diagram. So AB is here, CD is there. You're going to mark that right away. Then it says AD is congruent to CB, which is also given. So I'm going to mark my diagram for that. I'm going to say AD is congruent to CB. But now because those are different sides, I use 2 dashes. Okay, this is also given. Now they're telling us that BD is congruent to itself. So on that one, I'm going to use 3 dashes. And what is that called? Reflexive property. Very good. So if you go REF, prop. Now, they tell us our two oh, sorry. Do you need, you're good? Yeah. You want to just put down there, Marissa, just because I can write them a pass, okay? Now, this one is saying these two are congruent, okay? So when you do that, for now, all we know is side, side, side. That's all we know. So we're going to just say SSS. Okay. So side, side, side. All right. So now let's go and look at this one. So first of all, they tell us N is the midpoint of MO. Notice that they put down in step 3. Okay. And we can't mark anything with that until we do something with it. So we're going to hold off on that. Then notice they have LM is congruent to OP. That's given. And then they have LN is congruent to PN. That's here. And so this is also given. Now they marked already that LM is congruent to OP and that LN is congruent to NP. Whenever you guys see midpoint in a problem, there is a step on your cheat sheet right here. It's called midpoint theorem. And if they ever tell you that N is the midpoint of MO, what you're going to say is that this is congruent to that. Okay, so we're going to say segment MN is congruent to segment NO And in your little cheat sheet, it tells you that the reason is midpoint theorem. Now, how I abbreviate midpoint is I do MIDPT. And for theorem, I do THM. If you wanted to write that next to it in your cheat sheet, you could, so you know how to abbreviate that. Now, the last step, you guys, is always going to be what you're trying to prove. So even if you don't know what's going on, you're going to write this here, and it's triangle LMN is congruent to triangle PON. All right. And now, are those two congruent? Like, what do you think I'd put here? What did we put on the other ones? SSS. That's the only one we know at this point. And this is a side, 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 side. So I put SSS. So in that, where they have the two triangles congruent, for right now, we only know SSS. We're going to learn another one today, but that's going to be one of the two that we learned today. Okay. All right, so now let's look here. And notice they have two givens right away. And then they have three different givens up here. So let's start, and for number one, let's say Q is midpoint. And I just do MIDPT of PR. And they already have that that's given. Then we'd say segment PS is congruent to segment QT. And that's given. Okay, that's up here. And then notice this third given they already have down here. So this would also be given. So if they give you three things, you're going to have three givens. Okay. Now they want us to do midpoint theorem. And they tell us that Q is the midpoint of this. So what that would mean is PQ is congruent to QR. So down here, we're going to say segment PQ is congruent to segment QR. Okay, and that's midpoint theorem. We only use midpoint theorem when they say midpoint in the given. If they don't say midpoint, you'd never use midpoint theorem. Now notice they brought down the proof statement, and then this, you never write prove as a reason in a proof. You never do that. But for what we know so far, whenever they tell us two triangles are congruent, we're going to learn two today. And right now we only know one, and it's side, side, side. And if you notice, it's side, side, side. Okay. All right. Now, let's go here. And it says, does the diagram give enough information to show that the triangles are congruent? Now, yesterday, I was telling you guys some things that are common reasons in our proofs. And one of them is anytime two triangles share a side, you can mark that that side is congruent to itself. Do you remember what we called that? Starts with an R, reflexive, okay? Now, what we have to say here is this enough to say side, 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 side? And it is. So over here, we would just write SSS. Our answers for this is either SSS or not possible. And I'll tell you guys what I see when I grade this is some kids just start marking stuff that is congruent that really isn't, or some kids will not know what you can mark congruent and what you can't. So make sure that you really listen to what we can and what we can't. So now if I look at this one, again, notice these two share this side. So I can again say WY is congruent to itself by reflexive property. But then what will happen is some kids will say, well, if those two sides are congruent, I bet these two are. Or they'll think, I bet Y is a midpoint, so I'm going to say these two are congruent. You can never count on a midpoint unless they told us it's a midpoint, okay? So there's nothing we can say about these two sides. So this is only two sides of one triangle congruent to two sides of another triangle, and that's not possible. And if you guys want to, if you say NP, that's not possible. Now, is this one already marked side, side, side? It is, right? It's already marked, so we just say SSS. I look at this one, notice two sides of this are congruent to two sides of that. And the hardest part is like deciding, can I say those two other sides are congruent or can I not? They're not sharing a side, so we can't say that. We don't know anything about a midpoint. So there's really nothing that's telling us these two are congruent. So this is NP. Try not to just start marking things congruent because you want them to be, because that happens sometimes. Here, notice these two triangles share a side. Can I mark that side if they share it? Yes. So I can do that. And now do you get it? It's side, 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 side. Very good. All right. So now we're going to learn the second type to show that two triangles are congruent. Okay. And this is called SAS. And what it stands for is side angle side. Now, for this to be true, this is really important. You have to have a side angle side, and that angle has to be right in between the two sides. So side angle side. Notice here that angle is right in between the two sides. Side angle side. Down here, we have a side angle side. The angle is right in between the two sides. Side angle side. It's right in between the two. So now today we know two. We know side, 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 and we know side angle side. All right, so if we look at this, notice we have two different givens. The first one is AE is congruent to EC. So we're going to write given. And notice on this proof, they put both of the givens under the same step. I actually do that all the time when I do a proof, but they don't always do that. Sometimes they'll write them as two separate steps and write given twice. Now, this next step is something we haven't talked about yet today, but do you guys know anything about angle 1 and 2? They're vertical. And what do we know about vertical angles? They're equal. So I can mark that those two are congruent. And then what I would do you see how angle 1 is congruent to angle 2 here? Now on that cheat sheet, I put the common steps. I notice you have one for vertical angles, and it's called vertical angles theorem. So let me just show you how I abbreviate this, because you can't abbreviate more than me. I do VERT for vertical. I do an angle apostrophe S for angles all the time. And then for theorem, I do THM. now notice they brought down that the two triangles were congruent. And what we know so far is two different ones. We know side, 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 and side, angle, side. If I look at the diagram, this is a side, this is an angle, that's a side, and the angle's in between the two. So do you get that would be this one? So we write SAS down there. Now let's look at this one and notice it has two givens and two givens here. So I'm going to write down PQ is congruent to RS and angle PQS is congruent to angle RSQ. Okay. Yep. So notice PQ is congruent to RS is marked. And angle PQS, which is right here, is congruent to RSQ, which is right there. So that's marked. Now they're saying QS is congruent to QS. So first of all, I'm going to go here and I'm going to put two dashes there because I already have one. And how can I say a side is congruent to itself? Yep, Jason. Reflexive property, right? Yep, very good. Reflexive prop. Now notice they put the prove statement last, and I can do one of two things. Are they showing that three sides are congruent or two sides and the angle right in between? Yeah, isn't it side, angle, side, right? So you can just go side, angle, side. Now, let's go here. This one is about bisecting, and I think I put this on the cheat sheet. Yeah, so this is that bottom one right here, definition of segment bisector. So first of all, it says QT bisects SP, and that's given. And then here I'd write SP bisects QT. I use BIS for bisects, just so you know. Now, when they tell you something bisects and a segment, so they're telling us QT bisects this. To bisect a segment is to cut it in half. So if this cuts this segment in half, that tells us those two pieces would be congruent. So that's what I could, oh, and actually they did the other one first, but this one, PR is congruent to SR. Right here for number 4 would be that reason on the bottom of your cheat sheet on that page. And I do DEF of, for segment, I do SEG, and for bisector, I do BIS. Now they also say that SP bisects this, which means SP cuts this in half. So we could say QR is congruent to RT, and that's what they said here. So this too would be definition of segment bisector. Okay. Now, when we get to step 5, we have to know that one other thing is congruent. And when you think about it, what we have so far is we have SSS or SAS. If it's SSS, we would have to know something that makes these two congruent. If it's SAS, we'd have to know that these two angles are congruent. Is there anything we know? Do we know either these two are congruent or those two angles? Vertical angles. That is what we know. This is congruent to that. Okay, because of vertical angles. Now, when I list this, I have to use 3 letters. So I'm going to call it angle QRP is congruent to angle, and I could call this SRT. SRT. And like Nathan said, that's vertical angles, and it's theorem, THM. Whenever there's vertical angles, the reason is vertical angles theorem. Now, notice they put the proof statement down. And isn't this side angle side, right? So that would be SAS. Okay. Now, when we are doing the next type where it's not really a proof, it's just giving you a picture and you have to decide, are they congruent or not? These are things that you can assume. And I think this is in your cheat sheet too. Yes, this is on the back side of here, okay? One of the things we can assume, just like we did in the back, or that last proof, is vertical angles are congruent. You can always assume that. If this is something we haven't seen today, but let's say that they told us this line and this line were parallel. Do you remember what I said yesterday? If lines are parallel, what kind of angles do you want to look for? Anybody remember? Do you remember how we learned consecutive interior, corresponding alternate interior, and alternate exterior? Do you remember which one I said that we use in these? No. Anyone else remember? It's alternate interior. Okay, so anytime lines are parallel, you want to look for the alternate interior angles. But you can only mark those if these 2 lines are parallel. Okay, the reflexive property is the one where, like, if these 2 triangles share that side would be congruent to itself. And then down here is something we haven't talked about today, but I think you guys all know this. Do you know if this is a right angle and it forms a straight line? Isn't that a right angle too? So let's go to this page, and here's what they want us to do. We want to say, first of all, are these congruent by side, 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 side angle, side, or is it not possible? Okay. So if I look at this, is there anything else I can mark congruent? The line in the middle. And then what would that be? Which one of these? SSS, it's all the sides, right? Very good. Can I mark something here? You sure? The middle line. Okay, now these 2, there's nothing I can do to say these 2 are congruent. I can say that's reflexive, but I don't know anything about this. So this one would be not possible. The hard part of this is knowing what you can assume and what you can't. And like I said, that's what this list is for. It's on the back page of your cheat sheet. Do you guys see something here that's congruent? Yeah, vertical angles. Do I have that on that cheat sheet? Oh, I do. Okay, perfect. Vertical angles is true. And now, which one is this? Side angle side, right? Very good. Okay, we see parallel lines. Anytime you see parallel lines, we're going to think of alternate interior angles. Do you guys get the alternate interior are those two? Do you get that? And now I have this congruent. Is there something else that's congruent there? The middle line. And I'm going to use 2 dashes for that. Now I'll try to look at just one of the triangles. Is this one of them? Isn't it side angle side? Very good. Okay. Do you guys see something else that's congruent here? The middle line. Now this is a trick question. For you to do side angle side, it has to be where the angle is in between the two sides, okay? This angle would have to be up there. When that angle is not in between the two sides, it's not side angle side. In fact, what this would be, if you read it, whenever you read these and try to figure it out, you go the shortest way possible. So we do this as side angle, side angle, which is not one. Or if we read it this way, it's angle side. And if you look at that, just remember this one does not work because you can't swear in math, okay? Thankfully, it doesn't work. So that one doesn't. So if you ever get angle side, it doesn't work. All right. So for this one, we're just going to say not possible. Now let's go down here and notice if this is a right angle, that makes this a right angle. Is there something else there I can mark? Middle line. Is this one of them? Side angle side. Good job. Okay, last page, I think, finally. Sorry. Do you guys see something I can mark here? The middle line. And then which one would this be? Side. Very good. Something I can mark here? The middle line. And what is that? Side angle side. Very good. Something I can mark? And what is this one? Side angle side. All right, how about this one? Not possible. Isn't this going to be ASS again? Isn't this an angle side? That angle has to be right there. The angle has to be right in between the two angles. Remember, you can't swear in math, so that one doesn't work. So you're going to get a worksheet today that's back to back. Actually, it's got 3 sides. And it'll tell you guys on top of each page in my writing which ones to do. So make sure you look at that. You guys get so good today.